For lesson 5.1 and 2, this video will cover that, and we are going to look at solving inequalities. Alright, you've seen these before in middle school, the less than, greater than, less than or equal to, greater than or equal to, and we're going to solve these. So let's review equations and inequalities. So we have talked about solving equations before, and an equation, remember, only has one solution. So we say it's like a balanced scale. Alright, so both sides have to be exactly the same. So if I have an equation, I would have something like x equals 2, and since they have to have the exact same value, 2 is the only number that would balance out this scale. But an inequality has many solutions. So we say it's like an unbalanced scale because one side is heavier or bigger or worth more than the other. So this would be if we had something like maybe x is less than 2, okay? So this side is heavier. So I could put 2, right, and it would be heavier, but I could also put any number that's bigger than 2. So I could put 3, I could put 4, I could put 5, I could put 475. As long as it is more than 2, it's going to make this side of the scale heavier. So an inequality has many solutions. That's why we have to use the less than and greater than symbols instead of an equal sign. So when we go to solve inequalities, we have two important things that we need to remember, and it's the big but theorem and the flip-flop rule. Now, the big but theorem is not an actual theorem. You won't find it in a math textbook. I just made it up as a way to remember. Solving equations is just like, solving inequalities is just like solving equations. You're going to do the exact same thing with the opposite operations. But, and it's a big but, if you multiply or divide by a negative number, then you must flip the inequality sign. So you have this example, negative 4x is greater than or equal to 40 in your notes. Okay, we're going to solve it just like we solved equations, so I got to get x by itself. So to do that, I'm going to divide by negative 4. So that part is exactly the same as solving equations. Alright, but here's the big but. Because I divided by a negative 4 instead of greater than, I'm going to flip this over and say it's less than, and then 40 divided by negative 4 would be negative 10. So you're going to use the same rules that we did for solving equations to get x or whatever variable it is by itself. Alright, but you have to remember, if you multiply or divide by a negative number, then you must flip the inequality sign. And the second rule is what we call the flip-flop rule. Again, not a real thing. You're not going to find it in a textbook. But sometimes it's beneficial to be able to flip-flop what is on either side of the inequality. Okay, so if I have something like, let's say 11 is greater than b, that's how I would read that. 11 is greater than b. For different reasons, depending on what we're doing, I might want to put the b on the other side. Might want the b on the left. So if I do that, I can switch which side of the inequality they are, but I also have to switch the inequality sign. So if 11 is greater than b, then b is less than 11. It's kind of like if I'm reading it backwards. If I read it left to right, it would be 11 is greater than b, but if I read it right to left, it would be b is less than 11. So that's why I wrote it that way down here. So big but theorem and flip-flop rule. Not technical math terms, but things that you're going to want to remember to be able to solve inequalities successfully. Alright, so when we're solving inequalities, okay, put the big but theorem again because it's that important for you to remember it. Okay, and we're also going to graph the solutions on a number line. Okay, so first thing we have to do is get the variable by itself, and you have this example right here. So 5 minus 3x is less than or equal to 13 plus x. So we're going to use our same rules that we did for solving equations. So I'm going to go ahead and move this x to the other side, so I have all the x's on the same side. So now I have 5 minus 4x is less than or equal to 13. And then I'm going to subtract 5 from both sides. So now I have negative 4x is less than or equal to 13 minus 5 is 8. Last step is going to be to divide by negative 4. that means that x is greater than or equal to, because I have big but here, I divided by a negative, so I have to flip it over. 8 is greater than or equal to negative 2. So that was all step 1, get the variable by itself. Step 2 says check the order. So you don't have to, but most people find it easier to have the variable on the left. So x is greater than or equal to 2. We already have that set up that way. If you had it backwards, if you solved a little bit differently and had negative 2 is less than or equal to x, that's fine. You can still graph this, but some people find it easier. So if we need to flip-flop here, we can, so that the variable is on the left. Step 3, I'm going to circle the number on the number line. Now, this number line is blank. It doesn't have any numbers on it, so we're going to fill them in. And here's what we're going to do. We're going to take our answer, so negative 2, and I'm going to put it right in the middle. Okay, then I'm going to fill in the number line from there. So negative 2, if going this way, would be negative 1, 0, 1. This would be negative 3, negative 4, negative 5. So I'm going to circle the number. So I have a circle at negative 2. Okay. Then, step 4, I have to decide whether it should be an open circle or a closed circle. So if we go back here and look, open circle means that negative 2 is not included. Okay, so would negative 2 be a solution to this inequality? So if I had negative 2 is greater than or equal to negative 2, is that a true statement? Well, yeah, it is. Negative 2 is equal to negative 2, so this is a true statement. An open circle would be if negative 2 was not a true statement, and the only way for that to happen is if the or equal to part was gone. So if I had negative 2 is greater than negative 2, that would not be true. Okay, and so how it works is open circle is for greater than and less than, and closed circle is for greater than or equal to and less than or equal to, because that or equal to means that this is a part of my solution, so I'm going to go ahead and shade it in. I'm going to fill in that circle. So they get a closed circle, these symbols get an open circle. Alright, then last step, step 5, is shade appropriately. What does that mean? Well, negative 2 is not the only answer that I can use to make this inequality true. I can use any number that is greater than, or sorry, x has to be greater than or equal to negative 2. Okay, so any number I plug in has to be greater than or equal to negative 2. Alright, is negative 1 greater than or equal to negative 2? Yes. Is 0 greater than negative 2? Yes. Is 1 greater than negative 2? Yes. So my shading is going to go this direction, and I'm going to put an arrow because it has to go that way forever. And that is all there is to solving inequalities. So we're going to solve just like we did equations, except for the big but. If we multiply or divide by a negative, we have to flip the inequality. Okay, and then we're going to graph it on the number line. So we're going to graph the solution on the number line as well. You have a bunch more examples for 5.1 and 5.2 in your notes. Those are what you're going to work on now, and we'll go over the answers in class. You also have a little summary where it asks you what is the same about solving equations and inequalities, and then what is different. So once you're done with all the example problems, you need to go answer those 2 questions as well. And that is all.